In this example, we discuss how to use GeoGebra to find normal probabilities for sample means. We'll use this example to demonstrate. It says the number of cars arriving per hour at Burger King's drive-thru is right skewed with an average of 20.4 cars per hour and a standard deviation of 5.7 cars per hour. Can you compute the probability that 22 or more cars arrive in a random hour? Unfortunately, we can't because it says it's right skewed. Since it's right skewed, we don't have a normal distribution here. However, if we have a large enough sample, then we can use the idea of a sampling distribution and the central limit theorem to be able to use a normal distribution. And then we can answer a question like that. So let's look at the sampling distribution for sample means of size 42. So here n is 42, which means we'll be looking at samples of size 42. So this is 42 randomly selected hours, and then we're going to look at the number of cars that went through the drive-thru in each of those hours. And we'll find the average of all of those numbers, and that will be x bar. So what is the sampling distribution of x bar? Well, its mean will be the same as the mean of the underlying distribution. It'll be 20.4 cars. The standard deviation, however, will be different, and it will be given by the formula that we find on our formula sheet. The standard deviation of x bar, also known as the standard error, it will equal the standard deviation of the underlying distribution divided by the square root of n. So that underlying distribution has a standard deviation of 5.7, and since we have a sample size of 42, we're going to divide that by the square root of 42. That gives us a standard error of 0.8759. 0.8795. Sorry. The shape will be normal because our sample size is large. 42 is greater than or equal to 30. 30 is the cutoff. It's the rule of thumb for the central limit theorem. If you have a sample size greater than or equal to 30, then the central limit theorem tells us that the sampling distribution will be approximately normal. So the shape will be normal. It will be bell-shaped. So it will be normal, bell-shaped. We can use a shorthand notation, n standing for normal, 20.4 for the mean, and 0.8795 for the standard deviation. So now that it is normal, we can answer a similar question. What is the probability that a random sample of 42 hour time periods results in a mean of 22 or more cars? So to answer this question, we'll go to GeoGebra. We'll go to the three vertical dots. We'll go to the probability calculator. We'll open that up. We go to statistics. To distribution. This is the normal distribution. We have a mean of 20.4 with a standard deviation of 0.8795. Now we're trying to find the probability of having a mean of 22 or more. So it's going to be more than 22. So we'll put the 22 in here, and we can see that that's the region that's shaded in GeoGebra. It's this part of the distribution that's more than 22. So we put 22 here. X is greater than or equal to 22, and we see our probability appear in this box. So what is that probability? It is 0.03444. Now, we have another option. Instead of using this rounded value for the standard error, we could actually put in this entire expression directly into GeoGebra, and it will give us less rounding error. So we can put the 5.7 divided by square root let's see, I'm going to go SQRT 42, and we get pretty much the same answer, at least to the 4th or 5th decimal place.